Right. Now we should see complex numbers theory. What exactly we should know so that we can solve any question which is related to complex numbers in the exam point of view. So, starting with I is an imaginary number which is given by square root of minus 1. So I square is I into I, which is square root of minus 1 into minus 1, which is minus 1. So if I go for I cube is I square into I, which is minus 1 into I, which is minus I. So I power 4 is I square into I square minus 1 into minus 1, which is 1. And if you see this, the pattern generally repeats. So if I see I power 5 is I power 4 into I, which is I power 6 is I power 5 into I power 4 into I square, which is 1 into minus 1, which is minus 1. I power 7 is I power 6 into I, which is minus I, and I power 8 is I power 7 into I minus I into I, which is minus I square, which is 1. If you see this pattern clearly, I can see that after every 4 numbers, this pattern repeats. So for example, if I need to find I power 73, so I can't go on doing till I power 73, right? So we need to divide 73 by 4. When I divide 73 by 4, I get remainder as 1. If the remainder is 1, it is same as I power 1, which is I. Therefore, I power 73 is I. If I need to find the value of I power 1765, so I need to divide 1765 with 4 and see the remainder. But if you use the divisibility rule for 4, to find the remainder, we can just divide the last two numbers and see the remainder. So just divide 65 with 4. When you divide 65 with 4, you get remainder as 1. So I power 1765 is again still I power 1, so which is I. So hope it makes sense so far. Perfect. Now, yes. So the next concepts which you should expect you to know. So let me do more questions. I power 769. So divide 69 with 4. If you divide 69 with 4, so you get again remainder as 1, which is I power 1 is I. Take I power 212157 59. If you divide with 4, 59 with 4, you get I cube. I cube is I square into I, which is minus I. So I power 2159 should be minus I. So if I take I power 766, if I divide with 66 with 4, I get I square. As a reminder, I square is minus 1. Okay, hope you are clear with this concept. Now let us do operations on complex numbers. What are the operations which we are expected to do operations on complex numbers? So when I say operations on complex numbers, the basic operations like addition, subtraction, multiplication and division. So if I need to add two complex numbers like a plus ib plus c plus id, we just need to add their real parts and add their imaginary parts. So it becomes a plus c into I into b plus d. And if we need to subtract them, subtract their real parts and subtract their imaginary parts. So it becomes a minus c plus I into a minus c plus I into b minus d. If we need to multiply two complex numbers a plus ib into c plus id, this becomes ac plus iad plus ibc plus I square bd. I square is minus 1, so this becomes ac minus bd plus I into bc plus ad. So far it is simple. So some exception in this is, not exception, is a rule you can remember. What is a plus ib into a minus ib? A plus ib into a minus ib is a square minus ib whole square. So a square minus I square b square, which is a square plus b square. Means, for example, if I need to find the value of 8 minus 2i into 8 plus 2i, no need to multiply, just do a square plus b square, which is 8 square plus 2 square, 64 plus 4 is 68, so a square plus b square is 68. Now, before we learn doing division of complex numbers, we need to know the few terms which is called as a conjugate of a complex number. Conjugate of a complex number. So what is a conjugate of a complex number is, suppose if I have a plus ib, so with what complex number I should multiply a plus ib to make it a real number? I see that I need to multiply a plus ib with definitely with a minus ib, so that it becomes a square plus b square, which is a real number. So the conjugate, the complex conjugate of a plus ib is a minus ib. So the conjugate of 8 plus 4i is 8 minus 4i, and the conjugate of 9 plus 2i is 9 minus 2i is 9 plus 2i, and the vice versa. Now let us see how to do divisions. If I need to do division of 2 plus i divided upon 1 minus I, so I need to find the conjugate of the denominator, which is 1 plus I, and I need to multiply 1 plus I with both numerator and denominator. So multiply 1 plus I in the numerator and 1 plus I in the denominator. So we get 2 plus I into 1 plus I upon 1 minus I into 1 plus I. 1 minus I into 1 plus I is 2. And multiply same thing in the numerator. 2 plus 2i plus I is 3i. 3i minus 1. 2 minus 1 plus 3i by 2. So 1 plus 3i by 2 should be the answer. Hope it makes sense. So when to do division, the simple logic is we need to take the conjugate of the denominator and multiply it in the numerator and denominator. So the next concept we should know in complex numbers, or we can expect in exam, is modulus of a complex number. Modulus of a complex number. So when I say modulus of a complex number, it says the distance of the given number, complex number, from the origin. Suppose if I have a plus ib, assuming both a and b are positive, it lies somewhere in the first quadrant. So the distance from the origin to the complex number is said to be the modulus. So it is given by under root of a square plus b square. So for example, modulus of 3 plus 2i is square root of 3 square plus 2 square. So which is root 13. Now last concept is solving quadratic equations which have complex roots. Solving quadratic equations which have complex roots. Solving quadratic equations which have complex roots. So if I need to solve a question like x square plus 2x plus 5 is equal to 0. So if I try to solve, if I apply quadratic formula, x is equal to minus 2 plus or minus square root of b square minus 4ac by 2a, which is 2. So which will give me minus 2 plus or minus root of minus 16, which is 4i by 2, which is equivalent to minus 1 plus or minus 2i. So which is if I, root of minus 16 is 4i. So these are the two complex roots. So minus 1 plus 2i is one root, and minus 1 minus 2i is other root. So these are the concepts which you should know, so that you can tackle any question that is related to your exam point of view is considered.